Hi guys, welcome back to the vector section of the SQA Higher Maths course. Today we're looking at properties of the scalar product. So some properties of the scalar product are as follows. A dot B equals B dot A. A dot bracket B plus C equals A dot B plus A dot C, so we can expand brackets. And A dot A equals the magnitude of A squared. Well, why is that? Let's have a quick look. Let's go back up to the scalar product. So if we were doing A dot A, we'd have the magnitude of A multiplied by the magnitude of A, and the angle in between those would be 0. The cos of 0 is 1, so we're just left with the magnitude of A multiplied by the magnitude of A. So that is where this one comes from. If you forget it, just do magnitude of A times magnitude of A times the cos of 0, and it will just come out as the magnitude of A squared. Right, let's apply these in some examples. So here we're given the magnitude of P, Q, and R. Calculate P dot Q plus R. So we can expand this bracket first of all. So that would be P dot Q plus P dot R. So P dot Q, so there's P, there's Q, so we've got 45 at 15. So there's angle of there is an angle of 60 degrees in between them. So P dot Q would be the size of P times the size of Q, so 3 times 2 times the cosine of 60, plus the size of P times the size of R times the cosine of 45. So cos of 60 is 1/2, cos of 45 is 1 over root 2. If you have done the trig section, you will know that from your exact value triangles. If you haven't, don't worry about that just now, just use your calculator to evaluate it. So 6 multiplied by 1/2 is 3. 12 times 1 over root 2 is 12 over root 2. Then multiply numerator and denominator both by root 2 to rationalize the denominator. And we end up with 3 plus 6 root 2. Question number 2, in the diagram below, A equals C equals 2 and the magnitude of B equals 2 root 3. Calculate A dot A plus B plus C. So again, expand the brackets. A dot A, as we mentioned above, would be the magnitude of A squared. A dot B is magnitude of A times magnitude of B times cosine of the angle in between, and similar for A dot C. Remember, vectors must point away from the corner. So A and B do point away. So we can just substitute in. A and C, A is pointing in, C is pointing away from the corner there. So if we just come down to this little diagram here, move vector A across and up so that it's here. This angle is 120. We'll have a straight line. This angle here will be 180 minus 120, which is 60 degrees. And vector A and vector C are both pointing away from the angle there. So we're going to have 2 times 2 times the cosine of 60. And then, again, if we know the cosine of 30 is root 3 over 2, this would be an uncalculated question. But you will get practice at this type of question, well, evaluating the cos of 30 and the cos of 60 when you're doing the trig section, guys. So don't worry about that. If you've not done it yet, just use your calculator. If you have done the trig section, substitute in, practice your surd skills, and evaluate without the calculator. Anyway, root 3 times root 3 is 3, so 4 3s are 12, divided by 2 is 6. 4 multiplied by 1/2 is 2, so we end up with 4 plus 6 plus 2, which equals 12. So have a go at exercise 6E, which is on the properties of the scalar product, and get in touch if you need any help.